Hello everyone, I hope you're having a fantastic day. My name is Michelle and today we're going to be talking about solving binomials using Pascal's triangles. So this is a bit of a hefty topic. There's not too much to memorize, but there's just going to be a lot of solving, a lot of writing down. So definitely make sure you have some paper on you or even a calculator. So let's get started. So first, we are going to be talking about Pascal's triangle. This is a tool we are going to use to solve binomials. And well, Pascal's triangle is exactly what it's called. It is a triangle of numbers, and they follow a very specific pattern. So what happens to Pascal's triangle is there's going to be a 1 at the top, 1s along the sides of the triangle, so on the very outmost sides of the triangle. And then for all the numbers within the triangle, we are going to add the top two numbers to make the bottom number. So let's draw that out. So our top number is 1, our diagonals are 1, and right here, we are going to add those 1s to make 2. And we just keep doing that. So we add 1s on our very outermost sides, and we add the top two numbers like that. So again, notice how we have 1 and 2. 1 plus 2 equals 3. For the other 3, we also do 2 plus 1 equals 3. So let me repeat that. The top two numbers add up to make the bottom number. And the triangle continues just like that. So let's move on to the next row. We have 1s on the outermost sides. 1 plus 3 equals 4. 3 plus 3 equals 6. And 3 plus 1 equals 4. And that completes our next row. Now let's keep going. 1s on our sides. 1 plus 4 equals 5. 4 plus 6 equals 10. 6 plus 4 equals 10. And 4 plus 1 equals a 5. Let's keep going. 1s on the outermost sides. 1 plus 5 equals 6. 5 plus 10 equals 15. 10 plus 10 equals 20. 10 plus 5 equals 15. And 5 plus 1 equals 6. And so Pascal's triangle can keep going on forever just like that. But for now, and for today's examples, we're just going to stick with this. So now that we have drawn our beautiful Pascal's triangle, let's analyze it. So first we have to define our rows in Pascal's triangle. And the way we figure out which number row we're looking at is using these numbers right here. These numbers will tell you the row. So since we have a 1 right here, this is row 1. 2, row 2. 3, row 3. 4, row 4. 5, row 5. And 6, row 6. And if you're wondering about our very topmost one in our Pascal's triangle, that is going to be row 0. Now, why in the world did we just label rows? Well, these rows are actually going to equal the power or exponent of our binomial. So if we had a binomial raised to the power of 2, we would use the numbers in row 2. Now, what numbers are we using? Why are we using numbers in row 2? The purple numbers, the actual numbers in Pascal's triangle, they are actually going to equal the coefficients of the expanded binomial. So let me actually write that out. If we had a binomial that was something like x plus a raised to the second power, we're going to be looking at row 2. And this binomial, when expanded, will have the coefficients 1, 2, and 1. And actually, we can notice that since this binomial is raised to the power of 2, this is actually a quadratic, which, if you know the pattern, would be x squared plus 2ax plus 1. So notice how the coefficients match up with Pascal's triangle. And that's essentially how we're going to use Pascal's triangle. Alright, so let's move on to examples. There is more to solving a binomial than just Pascal's triangle. Remember, it is just a tool. And there are formulas for this, but I personally think the formulas are more confusing, so I'll just work it out. And if you really want to see the formula, it is on the screen now. Alright, let's get to solving. Example A, we have y plus 3 raised to the 4th power. Now the first thing I'm going to do is color code everything. So our y is going to be green, our 3 is going to be pink, and our 4 is going to be yellow. So first we are going to find our coefficients, and we're going to do that by looking at Pascal's triangle. So notice that we have an exponent of 4, or our powers raised to 4. So that means we're going to look in row 4 of Pascal's triangle, and we see that the coefficients are going to be 1, 4, 6, 4, and 1. Notice how those are exactly the numbers in Pascal's triangle at row 4. So those are our coefficients. Our next step is to look at the y plus 3. And what I'm going to do next is write in my y and 3's next to all of the coefficients. So let's start with y. Y, 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 y. And now we're going to write in our 3. I'm going to put it in parentheses, just so we know they're multiplying. And before I forget, since we are having y plus 3, between all of our terms, we're going to have a plus sign. So let's just put that in. Alright, our next step is putting our exponents on the y's and 3's. So let's start with our y's. The exponent of the y's are going to start at the first term as the highest coefficient and decrease until at the last term it equals 0. So what that means is, what is our maximum exponent? Our maximum exponent is a 4 right here. So our y is going to start as 4. So the exponent of y is going to be 4. And now we're going to decrease the exponent as we move on to the next terms. So for our next term, the exponent of y is going to be 3. See, it's decreasing from 4 to 3. The next exponent is going to be 2, decreasing 3 to 2. Our next exponent is going to be 1, decreasing 2 to 1. And finally, as I said, the exponent of the y in our last term is going to be 0. And if you're cringing right now going, oh, you don't have to write y to the 0th power, that just equals 1. Don't worry, we're going to simplify that out later. So now that we've finished with the exponents of our y, we're going to move on to the exponents of our 3. So for the 3, the first term is going to start with the power of 0. And the last term is going to be the power of the maximum exponent, which in our case is 4. So our first term is going to have an exponent of 0. It's going to increase. So our next term is exponent 1. Next term is exponent of 2. Next term is exponent of 3. And our last term is going to have the maximum exponent, which in our case is 4. Now, if this seems a little bit confusing, there is a way to check this to make sure you did it correctly. Basically, the exponents of y and 3, they are going to add to equal the maximum, which in our case, again, is 4. So let's take our exponents for the first term. They're 4 and 0. When we add them together, they equal 4. So that's correct. The second term, we add the two exponents, 3 plus 1 equals 4. And we just keep doing that. And now we know that we did our exponents correctly, since they all equal our maximum, which is 4. So now the next step is to simplify. And we're just going to, normally algebraically simplify. We're going to start on the first term, which is on the very left. So the 1, we don't have to write the 1. And we have y4. And we know that 3 to the power of 0 equals 1. And 1 times anything is just anything. So we don't have to write that. So that's our first term. We add, go to the next term. We have the 4. y to the third power, and we have that 3 to the first power, which equals 3. And we'll simplify that more later. Go on to our next term. We have the 6. The 6 multiplied by the y squared, multiplied by that 3 to the second power, which equals 9. Going on to our fourth term, we have 4 y to the first power, which is just y, multiplied by 3 to the third power, which is 27. And our last term, we have 1. 1 times anything is just anything, so we don't need to write that. We have y to the 0th power, and anything to the 0th power is just 1, so we also don't have to write that. And we have 3 to the 4th power, which equals 81. And now we are just going to simplify some more. We have y4, that's going to stay the same, plus 3 times 4, which is 12, y to the 3rd power, plus 6 times 9, which is 54, y to the 2nd power, plus 4 times 27, which is 108, y plus 81. And that is our final answer. Now, that was a lot. Don't worry if it doesn't make too much sense right now. We're going to do 3 more examples. 2 of which you're going to do on your own, and then I'll work them out afterwards. So, let's move on to example B. So, example B is r minus 4 to the 6th power. I'm going to color code it like I did for the first example. R, which is our variable, is going to be green. 4, which is our constant, is going to be pink. And 6, which is our exponent, is going to be yellow. Alright, so do you remember the first step? The first step is we're going to look at our exponent, which is 6, and we're going to go to Pascal's triangle and look for the 6th row. What's in the 6th row? So we see that in the 6th row, our coefficients are going to be 1, 6, 15, 20, 15, 6, and 1. So those are going to be our coefficients. Remember our next step? Our next step is we're going to write down our r and 4. That's all we're going to do. No, don't do any exponents, don't do any signs, we're just doing r. We're just going to write r and 4 beside all of the coefficients. Let's go through and do our r's. R, 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 R. And now we're going to write all of our 4s. 4, 4, 4, 4, 4, 4, 4. Next up is our signs. So notice in the last example, example A, our sign was y plus 3. But in this, we have r minus 4. And what the minus is going to do is, we're going to alternate between pluses and minuses. So our very first term is going to be plus, our second term is going to be minus, and then go plus, minus, plus, minus, plus. So next, we are going to do the exponents on the r, which is our variable. Do you remember which exponent we are going to start with on our first term for our variable? Right, we are going to start with our maximum, which in this case is 6. And then we are going to decrease. So 5, 4, 3, 2, 1, 0. Moving on to our 4, which is our constant. Do you remember the exponent of the constant for the first term? Right, it's going to be our minimum, which is 0. So we're going to start with 0 and then increase. So 0, 1, 2, 3, 4, 5, 6. Awesome. So now we are going to simplify. 1, we don't need to write that. R to the 6th. We don't need to write 4 to the 0th power because that just equals 1. Minus 6 r to the 5th power times 4 to the 1st power, which is just 4, plus 15 r to the 4th power times 4 to the 2nd power, which is 16, minus 20 r to the 3rd power times 4 to the 3rd power, which is 64, plus 15 r to the 2nd power times 4 to the 4th power, which is 256, minus 6 r to the 1st power, don't need to write the 1, times 4 to the 5th power, which is 1024. I'm running out of space, so I'll write it down here. 1 r to the 0th power is just 1, we don't need to write that, times 4 to the 6th power, which is 4096. Now we're going to simplify some more. So r to the 6 is just r to the 6, minus 6 times 4, which is 24, r to the 5th power, plus 15 times 16, which is 240, r to the 4th power, minus 20 times 64, which is 1280, r to the 3rd power, plus 15 times 256, which is 3840, r to the 2nd power, minus 6 times 1024, which equals 6144, r, plus 4096. And this giant expression is our answer. So that was a lot of work, but I hope this makes sense to you. Alright, so it is now your turn. Please pause the video and work on example A. And if it does help you, I do recommend coloring in the variable, constant, and exponent, just so you can more clearly see what you're doing. Alright, I'm going to assume you pause, and I'm going to start working out. So, first step, color code. Our variable is going to be green. Our constant will be pink. And our exponent will be yellow. So first step is we're going to take our exponent and go to Pascal's triangle and look for the row. What row are we looking for? Well, since our exponent is 3, we're going to be looking at row 3. And our coefficients from row 3 in Pascal's triangle are going to be 1, 3, 3, 1. Next up, we're going to write our x's and our 1's by the coefficients. X, 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 1, 1, 1, 1. Next up, we're going to write our signs. Since the sign in our binomial is plus, x plus 1, all of our signs are going to be plus, 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 plus. What's our next step? Right, we're going to now do our exponents for the variable. And we're going to start with our maximum for the first term, so 3, and we're going to decrease. 2, 1, 0. Now we're going to move on to our constant, 1, and we're going to go from the minimum number to the maximum number. So starting at 0, 0, 1, 2, 3. And now we're going to simplify. So 1, don't need to write that, x to the 3rd power times 1 to the 0th power, just 1, plus 3, x to the 2nd power, 1 to the 1st power is just 1, plus 3, x to the 1st power is just x, times 1 to the 2nd power, which is just 1, plus 1, don't need to write that, x to the 0th power, which is just 1, don't need to write that, and 1 to the 3rd power, which is 1. Our answer is this expression. Alright, moving on to practice problem B. So now, please pause the video and try working out on your own, and come back once you think you've got the answer. Alright, so I assumed you paused, and now I'm going to work it out. Alright, so you know by now my first step is always color coding. Our variable is going to be green, our constant is going to be pink, and our exponent is going to be yellow. So we have g minus 6 to the 4th power. So first step, you guys should know this by now. First step is take our exponent and bring it to Pascal's triangle. Our exponent is 4, so we're going to be looking at row 4. And we see that the numbers in row 4 are going to be our coefficients, which are 1, 4, 6, 4, 1. Awesome. Next step is we're just going to write our g's and 6's by all the coefficients. G, 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 G. And then we're going to go 6, 6, 6, 6, and 6. So now that we've written those, we're going to do our signs now. Notice that in our binomial, we have g minus 6. And that minus means that we're going to have that alternating pattern, starting with the first term being positive, second term is negative, positive, negative, positive. Alright, our next step is doing our exponents. For our variable, we're going to start with the highest exponent first, which is 4, and decrease. So 4, 3, 2, 1, 0. And for our constant, we're going to start with the lowest exponent and then increase. So 0, 1, 2, 3, 4. Alright, now all we have to do is simplify. So, first term, 1, don't need to write that, g to the 4th power, times 6 to the 0th power, which just equals 1, so don't need to write that, minus 4, g to the 3rd power, times 6 to the 1st power, which is just 6, plus 6, g to the 2nd power, times 6 to the 2nd power, which is 36, minus 4, g to the 1st power, which is just g, times 6 to the 3rd power, which is 216, plus 1, don't need to write that, g to the 0th power is just 1, don't need to write that, times 6 to the 4th power, which is 1296. Now let's simplify a little more. We have g to the 4th power minus 4 times 6, which is 24, g to the 3rd power, plus 6 times 36, which is 216, g to the 2nd power, minus 4 times 216, which equals 864, times g, plus 1296. And this expression is our final answer. So, hopefully you did it right on those 2 practice problems. Of course, if you would like more practice, there's plenty of online resources. If you just look up, solving binomials or just, Pascal's triangle or something like that. Alright, so that's all I have for you today. I hope this video wasn't too long, but, most importantly, I hope you learned this concept because, it's pretty important. So, anyways, thank you so much for watching and have a wonderful day.